or morning, depending on where you're joining from. And welcome to, well, this is technically not the first webinar for June. It's just we moved the last in May forward a bit. And I will quickly introduce the presenter, the speaker for today's session, and hand over to him. If you have questions, as usual, put them in the chat. And maybe at the end or whenever he allows me to check for questions, we might take in some questions in between the session. But there is always a dedicated Q&A session at the end. And today's topic is on data modernization at traditional banks, from legacy mainframe to cloud. And as you can see, this is the agenda. I am in the part where I'm doing the intro. So my plan is to be done with this intro in about 2 minutes. And then this whole session is mostly on the topics. So the presenter is going to share what they have planned for us and Q&A at the end. This is, for those of you who are new to the community, I'm going to share this. This is where we are present. So we have a dedicated website that makes it easy for you to see all the sessions and the recordings. And we also are officially on Fabric Community LinkedIn. So I will share this. All right, so to the main reason we are all here, and Vishal is here already, thank you. He's the VP of Software Engineering at Broadridge. He has over 20 years of expertise in enterprise architecture and digital transformation. He leads cross-functional teams, enabling delivery of secure, scalable solutions that optimize operations and enhance client engagement. I don't have it here, but I know he likes to share his knowledge because that's the only reason we have him here. Unfortunately, I don't have it in the slide. He focuses on integrating innovative technologies to align with strategic business goals, which, someone at the VP level where he's going to be managing stakeholders, and he's also skilled in driving seamless system integrations and cost efficiency. I'm so glad that we have him here today because we're going to be tapping into his wealth of knowledge and opportunity to ask questions at the end. So I'll get out of his way so that he can, have as much of the time that we have on this session. So over to you, Vishal. Thank you very much. I'm going to stop sharing my screen and turn off my camera, but I'm going to be in the chat and letting people know that they can ask you questions. And so please, over to you, sir.
Perfect. Thank you so much for that introduction, Michael. And hello, welcome everyone for this session for data modernization from legacy mainframe to cloud. Before we get into this discussion, I'll quickly introduce myself. It is a tough act to follow for what Michael just said about me. It's I've been in the industry for almost, as Michael said, almost 2 decades now. I'm working as one of the engineering leaders within Broadridge Financial Services, where I lead digital transformation initiative focused on modernizing legacy platform using cloud native, data driven, and AI enabled architectures. I've spent my career in fintech and financial services, working across the organizations, including Broadridge, JP Morgan Chase, PwC. And my work has been totally centered around enterprise architecture, APIs, domain driven design, microservices, regulatory technology. And I've built scalable systems that deliver measurable outcome. One of these systems that I built and I'm very proud of, rather I was in the team that we built it was building global API management gateway for JP Morgan Chase, which as of now, if you swipe in your credit card for JP Morgan Chase, it used to go through a pipes that was taking more than 12,000 transactions per second last I checked. And I am looking forward to sharing some practical lessons for these transformations with you guys, all of you that I have on the call today. Just a quick compliance thing. Wanted to say it out since this is getting recorded, that what I'm going to say right now are my personal opinions and coming in up and backed by my experience. I'm not representing Broadridge on the call, so we can be very open that what we talk and whatever I'm sharing is, as I said, it's through my personal experience for what I've gained in the industry. And I have all the many scars to show. That's what I tell people. It's not about how many years have you spent in the industry. It's about how many scars do you have to show. So I have a lot of scars to show. I've spent so much time in the industry talking about and moving data from legacy to the modern AWS or Azure platform, have built modern days distributed systems. So, and more than success, I've failed. So I've a lot of pride in calling that out, that I've also failed in multiple occasions of moving data and know where the skeletons could be buried when we're taking from data from the existing system to the larger, wider AWS system. It's not just that the systems have got it complex. Data is such a challenge now because the type of data has changed. Earlier it was okay, relational database about the customers, we're just keeping it in a structured format. Now it has changed, it has now become really distributed. So moving on today, in this session we'll talk about why do we even need to federate that data if it's sitting in mainframe or in distributed or in any database. Why do we have to truly have to federate it? The challenges, what if we don't federate the data sets? Then we'll talk through the process of transformation, practical usage of it. Last but not the least, how do we truly move that data from mainframe or any other system which is very close to the modern systems that are cloud native? But before even we get to the place where we define about how do we do these things, it's very important, imperative for us to understand why do we do it. Since technology, right, has evolved from age of industrialization to the age of information, and finally we all are living through this age of AI, the average life cycle of the technology was 10 years. It shrunk to 6. It went to 3. Now it's gone up to 6 months. When they're anticipating by 2027, the technology life cycle will be 6 to 7 months. Therefore, the definition of legacy has shifted. So whenever I talk to the people around, okay, this is the legacy infrastructure, legacy data transformation that we are doing, I often get a question, oh, are you moving from Java? Are you moving from .NET? That in my case, it's not, in my sense, it's not legacy. The reason is it is anything that I can access through normal JDBC protocol, through normal channels, push it on the queue, it becomes way simpler. I'm talking about the applications that has been developed before 2020, 2010, especially those built on mainframe or dated technologies, are increasingly seen as the candidates of modernization. Mainframe transformation has been a top priority in financial services. I'm not sure if you guys are aware of it, but still, as much as we want to agree and accept that yes, we have transformed the technology, the core business processes, at least in North America, it still runs on mainframe. So mainframe has been a top priority for financial services because of its operational inefficiencies, but processing is quite fast on mainframe. So people have a dilemma and a trade-off decision that they have to make. Um, Flexibility is less, but performance is more. So do we truly move this data out of mainframe or process, or we still keep it running? Plus, mainframes are very secure. So because of its operational inefficiency, inflexibility, and high maintenance cost with mainframes when compared to modern distributed system, people are thinking about transforming this system. Still, as I said, majority of the financial services are working on the mainframe system. So what are the challenges that we currently face when the data is kept in a silo system like mainframe, which is very difficult for us to access? Legacy systems often store data in isolated formats. So I'm not sure how many of you have worked with mainframe, but mainframe stores data in a format called vsam file. It's very difficult for us to get that data out, making it difficult for access and analysis. Compatibility issues, of course. If you cannot access the data through distributed system, there will always be compatibility issues. Many legacy systems were developed before current security standards were established, leaving them vulnerable for cyber threats and data breaches. So that also is very important for us to make sure we transform the data and have all the OWASP standard embed into our data system architecture. High integration costs. That is first most important. If I cannot integrate with the existing data, it becomes difficult for us to take care of it. System downtime. Whenever we have to install a simple program, it takes a downtime in the system. And then last but not the least, it is resistance to change. So it becomes very difficult for us to change the system because it is very difficult for us to change the system whilst it is work in motion, it's working. We have to bring it down if we want to change the system. So the shift from a familiar older system to a modern complex solution can create the fear of unknown. So that's where there is always a resistance for change. I don't know what will happen. Will it be able to process cross-border payments of $6 trillion in a day? What if it fails? If it fails, it becomes very difficult for us to regain that momentum and reprocess that $6 trillion. I'm just taking that as an example across the border. Last but not the least is scalability challenges. Many legacy systems have been designed with a limited scalability in mind, meaning they may struggle to handle increased workloads or larger data volume. But we have these are all the challenges that we have for data residing on the legacy system. But ultimately, we have to federate that data. And why do we have to federate that data? It is because there are certain drivers. One, as I said earlier, we'll have to federate the data for ensuring we have a better improved decision making. We have better risk management. We have to reduce technical debt. It becomes very difficult because we have to move data out, reprocess it, and make the OLTP data and OLAP data and make sure we make sense out of it. If we are not able to federate the data, bottom line is, and as much as anyone wants to agree to it, if technology is not my core business, I'll always be looking for the business revenue increase if I have to federate data. If my business is working fine and if I don't see any business expansion or bottom line reduction for federating the data, I'll not federate the data. So I always tell everyone there has to be a business revenue driver for federating the data. I don't want to just federate the data, increase the cost for us as a geek, we like it. So there has to be a reason. So there has to be an internal driver or there are external drivers. So global financial market mandates are forcing the organizations to make the changes. It's not on the internal drivers that, okay, I want to just to have business revenue, or I'm not touching the data because I don't see any benefit to my business. So that's where the regulatory and compliance comes into picture and say, by the way, we are an external drivers and we force you to transform your data. If you see on the screen right now, you will see the regions, they're coming up with their own version of opening up the financial services, which is considered a reserved industry by design. By design, financial services were always um, meant to be very closed. So PSD2 that came up in Europe, open banking that came up in Australia and UK. They forced the banks to open up their data and share the information. They're sharing it with a lot of caution, but ultimately that's a mandate that they have to do. In the same realm, we have AISG formed by NACHA in US region. We have regulated open banking even in Mexico. We have monetary authorization of Singapore Financial as a Service that is doing forcing the banking organization based out of their own geographical region to open up their system. So it becomes imperative for us to make sure we start federating the data. If there are no internal drivers, there will be external drivers. So those are the drivers why we have, what are the challenges in federating the data, why we have to federate it, both internal and external drivers. But when we start thinking about federating this data, that's where I love this slide. I'm not sure how many of you have read into An Elephant and Six Blind Men. I always share this and with an antidote over here because every time we talk about legacy, we think about one system in mind, but not all legacy systems are the same. As I said, right, the technology lifecycle that has shrunk, the applications, C++, Java, and other easier modern applications that were built, they were easier to modernize comparatively. Modernizing the legacy technologies that that runs your intricate workload is a complex task because it has organically grown over the years and has challenges of the in all three dimensions: people, process, and technology. So we have challenges in all three dimensions. So we have to check what dimension are we taking care of at any point in time. Like mainframe systems, they have a procedural architecture, tightly coupled code base. So if there is a technology driver to move it, then you have a different construct of how do you want to move the data. If it is regulatory, there is a different construct of moving the data. If it is just people, because people are retiring who have been working on legacy system. So people who have built the technologies are slowly and gradually moving towards their retirement, and therefore there's a fear of losing the subject matter expertise. Processes, if you want to just do the process, say for example, there are firms that are highly mandating, you should do CI/CD, very difficult in mainframe. They could be the reason for moderating. That's the last thing that I've seen. The driver for transformation is process. It's majorly the people and technology. So we will part people problem aside, we'll focus on technology. So whenever we start building the application, which in the current state is highly complex because it's very intertwined. And I'm not making this up. This is from the internet, a very complex system on the left. And this is a complex system. You can surf it off the internet. This is how the real true credit card system processing system looks like. So you have, I hope you guys are able to see my, bear with me for 1 second. Okay. So if you see, these are data sources, different data sources that you have on your system. These are the different nodes and program accessing those data sources. It's very difficult for you to see which is the source of truth, what is the authoritative data source, who owns that data, and how that data is moving, at what state a data is living. So if the application is built in the system, which is very difficult for you to federate, it becomes very challenging for you to even know the authenticity and integrity of the data. So when I say, and I'm not using that word just for using it, when I say spaghetti architecture, it is not a myth. It's not just that lives on the textbooks. I've seen that firsthand, the spaghetti architecture. On the right, let's switch gears. Let's say what is a target state? Target state is when you truly have your data federated, like over here. You have your data mesh, you have your transactional data, you have your reporting data, you have your cache, you have your analytics data sitting all in together in a beautiful world where it is facaded by a data mesh or a fabric in that case, where you can get access to the transactional and the reporting data. Plus, you know who is the authoritative data sources. What are the authoritative data sources? Who are the SMEs that manage that data set? That is truly will be future state of the system and application that we want to build. So what we're going to talk about next is very specific to this layer. That is our mesh data. All right, perfect. I'll open it up for questions in the middle of the conversation itself, somewhere around halfway through, so that we can talk before I move on to the next geeky part of how do we truly move that data out. All righty. So we talked about spaghetti data architecture. Now moving on. How do we start this transformation? First, we define the target state and architecture principles. What, as I said, what are the drivers for which we are moving the system? What are the architecture principles that we're gonna use? We start then the discovery of the process. What are the processes that are being running in my existing system? What are the type of data sources? Understanding what kind of beast are you dealing with? Is it a mouse or a cat or a lion? We don't know. Or a dinosaur. So we have to understand the existing systems, understand the business processes that are executing on it, map them to the program and data sources. And this is not just, as I said, right, this is not just academic exercise. I've lived through that a couple of times. So discovery is very important to know what all systems are we dealing with. Understand the intern program lineage and interdependency. So you have to know how the programs are interconnected, their lineage, how they are being formed from program A to program B, ultimately to the data source. We have to have that inventorization. Then we start with the modeling, how my target state would be. So we start with the defining what are my guardrails, rules of the road, Second, we start with the discovery process. What kind of beast are we dealing with? Then we inventorize it, data lineage and every other detail. Now, once you know the as is, we define target, what good looks like, what do we need, what are our business drivers, what future it is, how do we make it future proof. So we map that capabilities, we define the target capabilities, then we map the existing to the target capabilities, last but not the least, and that's where we get to the execution part of it. And before we get to the execution part of it, you guys might have heard a term that was coined by Martin Fowler, Stangler Fig approach, which is a very strong approach. And we'll talk about it, how we practically implement in the next slide. But strangulating the existing capability and then gradually increasing the new capability, slowly and gradually strangulating the existing one is the beauty of strangler fig approach. That is how we start the execution of transforming a system and ultimately federating the data sets. I'll take a pause. Any questions thus far?
I'm checking so far, no questions yet. But I can say, if you don't mind, I can squeeze one in. Uh, about the strangular fixated approach, I hope I called it correctly. The
Yes, you did.
Okay, oh, you're gonna talk about, all right. Maybe I should not ask my question then. Okay, please
No,
go
no,
ahead.
go ahead, Michael, if you have a question.
I was gonna ask that does it make a very big difference, versus say they put a hard cutoff and they just turn off the old system and everybody is expected to switch to the new one. So I've seen the one where both are running concurrently and they do a hard turn off.
So it goes back to your. I've done it both the ways, Michael, in my career. One is gradually turning it off. The other one is Swiss knife cutover. So you have to build a parallel system. So, but building a parallel system, it generally is not very agile in nature because you don't have two systems running the same capability and matching it together. It becomes very difficult for you. Then you have to make sure BAU is also done on both the systems. So that was a very costly affair when we did a Swiss knife cutover, saying, okay, this is the new system, this is the existing system, we shut down the existing system, we just do new system. And that's where a business driver of business continuity also comes into play. If my business continuity has to be, my business can does not have an appetite to discontinue the business, not even for a fraction of a second, I do a strangler fig wherein I strangulate the existing system and then slowly and gradually enhance my new system. So it's basically driven through your business capability and
And a
business
question,
continuity plan.
a question has come in. Should I read
Mhm.
it?
Sure.
Okay. Okay. So Akil is asking, so I think maybe he uses Databricks at work. So he's saying, have you used Databricks? What role do you think it can play in achieving this future state you spoke about?
So, Akhil, we'll definitely talk about that. We did implement Medellin architecture in one of the initiatives, and I'll talk through that. So, probably in coming slides, you will definitely see the reference to. Um, I didn't call out any product as such, but we did implement Medellin architecture for the data.
Okay, thanks. Okay. So I would say maybe we go on. I know someone's hand is up, but for now we cannot allow people come off mute till the end.
Okay,
So,
perfect. So if you guys can hold your new questions, we'll definitely take. I prefer having more conversations.
mm,
It's very seldom that I do online sessions. I generally prefer doing that in person. So in forums, I keep the questions, let it come. But if it is towards the end in this online fashion, I'm perfectly fine with it. We'll take the questions toward the end, and I'll leave more time for questions because I love that interactive session. I learn a lot through that as well. All right. So
thanks.
let me start going through Strangler Fig. So what happens is when we talk about Strangler Fig approach, it's incrementally modernizing your system by replacing the application and services in a phased approach. And I'm a visual thinker, guys. I cannot just go by the slides or um, by the text. I need to visualize it. So we'll go through the visualization of it as well. When I visualize it moving the I'm not sure you guys know about those turbines and all, but when you start moving the turbines, you start slowly and gradually opening the pipes. You don't know how will it function. The first first go with the immense water pressure. So we would have to, we will talk about that, how it practically looks. But the benefits are it reduces the risk. To Michael, to your question that you were asking earlier, it provides a way to reduce your risk while performing the transformation. It keeps the old services in play. What if exist new service is fouled? It has some issues with it. Your existing services can be turned on because they're not off. They have all the functionality. So your business continuity will not break. Adds uniquely new services while refactoring the older one. I don't like that example, but it's like fixing your engine while the car is in motion. Ensures incremental success. So you don't have to wait for the entire system to be built before you shut down the existing system. No, Strangler Fig is so unique in its nature because every time you strangulate a functionality, you are shutting down the existing system. So it makes it very easy for you to realize the benefits. And what I have realized working with the executives, everyone wants to see the quicker wins. No one would wait for you for 5 years to finish it up. By that time, the system will be obsolete. So that's where the technology's life cycle has made it very difficult for us to do anything but strangler fig when we're transforming the system. But there are important things as well. Those are considerations. So we have to make sure we have to have certain level of data synchronization amongst two systems. High degree of SME knowledge is definitely required. And then last but not the least, testing is of utmost importance. Both the systems have to be tested in parallel. So that is important for us. But how it truly works, right? That's where it becomes interesting to see. So this is how we truly implement the Strangler Fig approach. First thing we do is we identify the capability as is capability today. What is the as is capability that we are transforming? Second thing we do is we ring fence that capability. Ring fence as in that capability will just have one entry door, restricted entry and exit. One entry door only. That is one API access for the existing system. I'm not even introduced new system. For the existing system, any calling application would just use one entry, one UI, one API with a contract. So that's the first thing that we do. We ring fence, we do restricted entry. Third thing that we do is we add a decision point. We have to see where that capability is living. As of now, all capabilities will be living. Let me do that. Let me add this one to it. Uh, so single entry, this is the entry point. Now what we do is we add a decision point. Where is that capability living? Is it living in our new system or is it living in the existing system? So that decision point is being created. In the beginning, every capability will be living in the as a system. Nothing would be there in my to be system. Now, as I start creating the new capabilities in the new system, I start shutting down the existing system, and then more traffic will start flowing on the new system. We then do a data recon, we test it out. But with this, what you did was your strangler fig ensured that there is a business continuity in play. So you can build it for 5 years, 7 years, 8 years, how much you want. You would never even worry about your business continuity. You would, if you run out of funds, you can close the project or initiative. Still, you will have something in the modern system. 98% of transformation they fail because executive buy-ins, they get tired of funding those projects because they don't see success. So that number is critical. It was published in one of the McKinsey studies, if my memory is serving me right. I could be wrong, but that's what I read. Now, once we have completely transformed the system into the new system, we move this into a passive mode, the existing capability. It's not shut down yet, it's in passive mode, running all the capabilities into the new system. I would prefer running it for 6, 7 months till the time there's no challenge with the new capability. We then shut this entire capability down, the existing one or the old one. That's how we truly strangulate the capabilities from stage 1 all the way till stage 5. So that's your strangler fig approach, all the way from soup to nuts, from identification to strangulation of your existing approach. So this was all about approach of how we do this transformation. How do we strangulate the existing capabilities to the modern capabilities? Now the fun part begins. This was all about design. How do we start identification, drivers, external, internal, challenges, different type of systems, spaghetti architecture versus more linear or straight architecture. Then you have process of transformation. Now we'll switch gears. Now we'll go to the real fun part. Is about how do we truly do the data migration. Data migration is done through, and coming back to your question, Akhil, that's where you'll see Databricks in here. As of now, I just used Azure over here, but it can be AWS as well. So it's no affinity to any cloud provider. For this diagram, I just used Azure. So mainframe, as I said, oh boy, sorry, bear with me for 1 second. So you have mainframe data set that are living over here. What you do is mainframe also logs the data. So you have like in Postgres, you have write ahead logs or trigger logs. Mainframe also has certain a level of logging. So whenever they log any change, any create, update, or delete operation, the logs capture the information. It goes through the publisher, a controller daemon we call it. There's always a listener listening to the process. It picks up the data and then publishes it to the CDC route. We call it change data capture. Anything that changes, we capture it and then publish it. So that's how we capture the data in the existing system and push it out on your target system from the log. So you don't change anything that is working on the existing system. The system works as it is. You're anyhow using log, so you're not compromising the performance of the existing system. Using CDC, change data capture, you push it to the target cloud or any on-prem system of your choice. You can use Kafka. Kafka are the target agents. So as you move it to Kafka, you just host the data on your target system. What's interesting over here is when you move the data to your target system, it's a raw data. That's where your Medallion architecture will come into picture. When you move the data to the raw format, it is unprocessed. Now is the process of cleansing the data, running that transformation logic on it. It can be analytics, it can be transactional. Majority of this workload, when you're just doing a read from change data capture, it is analytics. So that is your data value chain. You go from raw data to bronze tier to silver tier. You do a little bit of spit polishing of the data, you massage the data, you process the data, you make it in a format that can be used by anyone in the enterprise. Now, once it is done, you move to the next level of data set. That is gold tier, which is for a given specific use cases. So as part of that use case data, we get the data information, we store that, we apply application level rules, what my consumers want, bringing in the consumer centric flow onto your data store, and then make it available to your target system. In this side, you have uh, this is what we call a reverse ETL as well, guys. If you are familiar with ETL, so it's a reverse ETL. You have the transform data load. Now you have to put it back into your transactional system. So reverse ETL and then put it in your transactional system where users can start looking into it. You can have Power BI or likes of BI tool on it. As I said, I used Azure, but that does not mean it's just Azure. You can have Cognos, you can have Looker, you can have Click, or oh boy, what is the BI tool for AWS? I'm drawing a blank. But you can use QuickSight. You can use QuickSight for it. So you can use any of the BI tools that can sit on top of your data lake or Delta Lake, now people call it, right? Delta Lake is what we'll be able to form with this. Raw data, you can create a delta lake. And then now there's a construct. I'm not sure majority of you might have heard about it, and we are implementing it right now. It's called a lake house. So you have the flexibility of data lake, and on top of it, you build a data warehouse for a very specific use cases. Because remember, data warehouse is a very costly affair. So you just for a limited use cases, you build a very small piece of warehouses wherever it is required. So this is truly how do we transform your system all the way from soup to nuts. We take your raw data, strangulate the existing system. While you're strangulating it, get the data out through CDC, apply that business logic on it from raw tier, that is bronze, to silver tier to gold tier, making it middle in architecture. Apply reverse ETL wherever it is required to get the data back into your transactional system, or have a reporting built on top of it. This is something, it's, as I said, this is nothing that it is just very academic. It is something that I've built and it is running. It is, in my experience, I've also done it to a level wherein we have handled more than, uh, I'm proud of that fact that we have built more than 10 billion position process through this, not million, but billions. So this is truly how the CDC and data transformation end to end goes through. And before I move to the next slide, I really want to make sure you guys understand it is not easy, it is not simple, it is complex to build that CDC. And data lake is even more challenging to build because you have to put the buckets. It becomes difficult for updating it, appending it. On top of it, when you build a lake house, you have to be very stringent and very methodological. How do you want to create the warehouses? For what use cases? That's where I always tell people it is never just a technology thing. Your business should be sitting with you, next to you, identifying what value do they want to drive from the data. Else, I'll highly recommend just dump your data in the buckets. Don't even think about object store. Don't even think about creating any view on it, be it through your iceberg format or anything, till the time your business people are coming to you and saying that is the business value that they want to drive from it. Else, you will just be penalized with a lot of AWS or cloud cost because data is everything but cheap. So please make sure you guys work your way through it whenever you're designing or implementing it. That cost is something that you guys should always think about whenever you're moving data to cloud, because it's the same data, changing the format, changing the views, and we might end up bleeding through our nose. So we did that once in my previous life. When we did this, we started bleeding through the nose. We had to do a lot of retrospective fix on to our pipeline to make sure our data is contained or our cost is contained and data is still federated. With that, I'll just end this with one very strong, oh boy, sorry about that. Very strong piece over here that says digital business is a composable business and business data is the foundation of that assembly line. Remember, you cannot draw out any business value if you do not federate the data. Your data is a new oil, but if you do not know what to have to do with the oil, how to distill it, or it becomes very difficult for you. So you should know when people say, oh, data is new oil. Yes, it is. Do you have proper refineries? Do you know what do you have to do with that data? That's where it is imperative for us to ensure it is linked to the business. That's where it should always be called a business data. It is the foundation of your assembly line. With that, I'll take a pause and feel free to connect with me. I'm on LinkedIn. I would love to have conversations on data. I'm a data geek. So feel free to reach out to me. I'll be more than happy to take more questions over here. If we run out of time, I'm even more happy to take those questions offline as well. Feel free to reach out to me. Michael, are we
Thanks.
okay to open up the
Yes, yes.
floor?
Now,
Perfect.
yes, now we can. So I know, Fajin, you had your hand up. Sorry that I had to tell you to wait, but now we are at that stage where, yes, yes, please ask your question. I see you've come off mute.
Thank you. So, nice presentation. So, Vishal, thank you for that. I have a question on the initial phase, right? When we define, discover, inventory, and uh, initialize and model and execution, that phase.
Mhm.
So, what are the strategies that we use? I mean, that you have come across in your experience on for defining and discovering, right? When there is a defining phase where how do you define it? So that's one question. And what is the strategy that you use for discovery? Then I have another question. It came down to the strangling phase. I'll ask as a follow-up, but yeah,
Okay.
those
S- So, I mean, that is really a good question. So, when we talk about discovery of the existing systems, there are uh, great tools available. For
okay,
mainframe, we use something called AWS Transform. It gives COBOL code. I'm not a mainframe guy. By my core, I'm a Java guy
right,
and a Python now, but PySpark is what we use for transformation. But that being said, um, we use AWS Transform to do business rule extraction, to draw the lineage, and have the functional spec drawn out. Initially, 6 years ago, we used to do that manually.
right.
So I have had army of people that have manually sat down and documented business rules of more than 15 million lines of COBOL code. It
Oh,
took us
okay,
8 months.
right,
So that was the discovery exercise because we need to know if I'm doing cross-border payments, I need to know what country has what logic or why something multiplied by zero point 0.5,
right,
right? And if people are not religious with writing the description or writing some narrative on the COBOL programs, it's very challenging for us to do it. So that was how we did discovery. Now, definition, that's where we sit with business or your product. What is the core functionality? And I'm very strict about this in my teams as well, finding that whenever I start the process, I start with an OKR methodology, which is objective and key results. Objectives, remember this, objectives have to be qualifiable, key results should be quantifiable. And objective, you define, I want to build the greatest, fastest car in the world. Okay, how do we do it? It becomes, okay, I need good tires. That becomes objective for next set of key results. So it's a hierarchical problem. You keep on defining it till the time you get implementable key results.
right. So can I ask you a question? That
Sure.
so during that mic that if I take the example of um, the mainframe migration, right?
Mhm.
So in that specific case, how do you identify, okay, this is my, I mean, the objective, right? The discovery phase is there is a overall objective in terms of just need to be migrated to a cloud, right? We are defining that. So is that the defining phase? I mean, or we
No.
break it down to individual cases? If you're breaking down, how do you even break it down? Is it based on business units or is it based
That's
on
a
some
very good
specific?
question. How do we slice the system?
Right,
Right. So that is indeed a brilliant question. The reason is there are two ways to slice the system. You do it vertically or horizontally. What do I mean when I say that? If your business owners are very strict and they have a thick line amongst their products, you slice the system vertically. I have a product owner who will do just P2P payments. A product owner that just does cards. I'm a product owner that just does commercial banking payments.
right,
That's very strict PO region. They do not share anything. You slice it vertically that this is your microservice or a domain that you run. What all
okay,
capabilities do you need to execute that? Horizontally, when there is gray area or gray lines, oh, by the way, we all will use the same payment system. By the way, we'll all use the same data set. Then fine, let's do it capability by capability. Okay, KYC would be horizontal capability, run across credit card, commercial payments, and investment banking.
right,
Then you build address verification, that becomes secondaries. Shipping, that becomes third. So That's how you cut the system horizontally. So it's all driven by how your business or a firm is formed. So that's
Okay.
how you slice the system vertically or horizontally. Does that answer your question?
Yes, that's thank you so much for that. Yes, that did answer mine. Okay, so if we take an example of like a discovery and we have sliced it on a vertical, I mean, make
Mhm,
it easier, right?
mhm.
How when you come to the discovery, right? The strategy would be, do we talk to the business along with the application on architects? How do you define that kind of
So first
discovery?
and foremost, Wayne, your discovery cannot be vertical or horizontal
Oh,
because
okay,
I'm not making that up because it's so difficult for you to even slice the system
okay. Hmm.
because they're so intertwined. So you have to invest some time to get the overarching system of how it works. In
Okay,
that, if you can draw the exist lines in the existing system, that is brilliant. I've done it both the ways. So there were few of the systems where I've seen it's easier for me to draw the line and draw that line. It becomes simpler for me to strangulate those capabilities without even knowing the exist entirety of the system. In one place where I was stuck, I was bound to learn the entire system before we strangulate it or before even we break it down into capabilities because no one knew what that 30 million lines of code was doing.
right. Okay.
Okay,
Uh,
Franjin, sorry if
this,
I want to like also give
Yeah.
others a bit of chance, but we might come back to you if there's more time.
Yeah, sure. Yes. Thank
Sorry,
you so
yeah,
much,
okay,
Shalin.
thanks. So I want to also read Brandon, and Brandon, if you want to come off mute and maybe give more context, that's also welcome. Otherwise, I'll just read your question. You have the opportunity and you can come off mute by yourself. You don't need me. So I'm going to read your question. So great. It's as if you've seen the question. So it says for the stage 4, the ASIs and to be processes are existing together. I think he's asking, are they existing together? And then does it mean that the to be model has been deployed already at stage 4?
yes, it has to be deployed, Brandon, because what happens is that's how we truly strangulate the capability. So when you start on stage 4 is where you start building your new capabilities without moving your clients. So both these capabilities will be running in parallel. You will test the outcome of both these capabilities should be the same. If I'm giving the dividends of a given stock of 25%, the outcome from both the systems should be the same. So that's how you validate for some time before transferring that capability to the new system.
And then maybe I should just squeeze this in. So you have the recon between the two
Mhm.
systems, even in the passive mode stage 5. Is it that the reconciliation, I guess, is reconciliation? Is it going to be done for every request or it
It
will
should
be
be.
cherry picking? Oh, okay.
It should be for every request, Michael, and that's where it has to be automated. You cannot have a manual recon process. It has to be an automated process. It has to process at the same time. And that's how in the cost structure, you'll always see a bell curve. Before the cost coming down, it will go up. And I'll share the paper with you guys over here. I love writing academic articles. I published one for transformation, and that includes the cost structure as well. So it has a bell curve. It goes up because both the systems will be running in parallel before it comes down. So there will be some time during a transformation where your compute cost will be higher.
Good to know. Akil, yes, you can come off mute. I see.
Um,
Oh,
yeah,
sorry,
thank
hold on. Sorry, Akil. I think Brandon came off mute shortly. Do you want to say something?
Hi.
Okay.
So I was wondering, if the production is still going, then I'm a little bit confused because if those two models are deployed at the same time, then production data could be duplicate, or does this recon means it needs to be validated with each other, and then you will use only as is data for the production line?
Yes. Yes.
Okay.
So the data is getting replicated, as I said, right? Brand, that is the bell curve where the two systems will be running in parallel. You'll be
Mm.
reconning the data and validating it that the data is the same amongst those two systems. And interestingly, if you recall, this was the decision point that we had, right? This is where we had the information around what will be living where. So if the capability is an existing system or the new system.
Okay. Thank you for your explanation. I think this triangular pattern is really brilliant. Yeah, thank you.
Thank you. It is a great pattern. I've lived through it, so I can vouch for it.
Great. So Hakil, yes, over to you. Your
Go ahead.
question.
Yeah, thank you. So I wanted to ask about more about the automated validation that you
Mhm.
spoke about. So you mentioned we are getting the data migrated to the new system using CDC workflow, right?
Mhm.
So
Yes.
CDC will have historical data and all, which will get accumulated over the course of time, and that will be in target system. So I was
Mhm.
wondering, when you want to do the reconciliation, you need to have both the datas equally present in both the systems, right?
Yes.
So that you
Yes.
can validate your scripts automatically and also accurately. So I was
Correct.
wondering, how do you exactly do this validation? Is it a row by row check of all the data that you do, or is it a sample amount of data that you check in order to just check the transformation logic is working or not? I just want to understand more about it.
So in the QA environment, Akhil, we test row by row. And
Okay,
in a production environment, because remember, both of these systems, C1 as is and 2B, will be running in parallel. So for
right.
a month or so before transferring the capability to the new one, I'll have end of day report for me if there is any data
Okay,
mismatch across all
yes,
the rows, to validate my transformation logic as well, data as well as logic. So I have a report that comes to me on at the end of the day. If it is not matching even one row, that means it's flawed. So to
right.
go and check. So it's not, it has a report that comes out. And if it is running fine for 1 or 2 months, I switch the capability then.
Got it. Yeah,
Make
makes sense.
sense?
Yeah.
Perfect. Okay.
Yes. Thank you.
Sure.
Okay. And I thought I saw your Bami's hand up. Or you've typed the question. Do you want to maybe read it? Or, I mean, say it so that maybe you give more context, or should I read your question? Maybe I'll read for now. Oh, yeah,
Hi
yeah.
everyone.
Yes,
Yeah,
we can
thank you
hear you.
so much, Michelle, for the presentation. So I was just thinking in my head, how do you manage the mapping of the schemas from the first system vis-a-vis the other system, like the new system, in terms of, let's say I have a customer table and the way customer entities and attributes are defined in system A is very different from system B. How do you manage that mapping? Because I've worked on projects whereby data is coming from, say, for example, in Dynamics environments, and the new system is an SAP solution. These two systems have different entities. The way the entities are mapped, they are all different. And now we want to run both systems concurrently. I'm just trying to understand how to apply this strangler approach in that instance.
That is a great question again. If you remember this, right, process of transformation, identification and modeling is important for us. This stage that you see over here on the screen. The reason is this is where you define your target capabilities. I don't know why it's giving me a hard time. Presentify is not working, but over here is where you define your target architecture, you define your target data model, and then you do the mapping of every attribute. Because over here in discovery phase, what Fahin was asking, in the discovery phase, you would know what your data elements are. I'll give an example. In one of my previous slides, when I did that transformation exercise, the current system had 69,000 data elements. Unique were just, you'd be surprised or not, I don't know. Unique were just less than 600. And then target, when I started working on it, target was roughly around 3 to 400 data elements is what it needed to run the system because they were duplicating the data. So what we did was we realized, uh, and there were composite fields, there were linear fields, dependent, interdependent fields. So we used that mapping exercise saying this out of 69,000, this is mapping to, so you would see a lot of convergence of the data. So we do that convergence, and that's what we do at transformation and mapping it back to the original system. So anytime you do a transformation, it becomes very important for us to do that reconciliation after mapping. So mapping is important, but how do you map is that transformation logic. We talked about, right, bronze, silver, and gold tier. So which tier would you apply that logic to, depending on where do you want to consume it? You apply that logic, you validate it after doing the mapping. So mapping is important. So mapping we do from target state when we define depending on the business model. And when we define the target state, Ayubin, that's for everyone. I should have probably called that out earlier, is knowing what good looks like. You have to cut the ties with the existing system when you define the target state. If you don't cut the ties, it will be garbage in, garbage out. So you have to start thinking about the new system as if you're building something very new, nothing to do with the existing system. Else you will take that old technical debt with you to the new system. Hope that answers your question.
Yes, it does. Just one follow-up question.
Sure.
So, are there tools you recommend for doing this mapping? Because from experience, most times you're on a project, you are exposed to the database, for instance, and there's no data dictionary. So it's quite difficult to even understand the fields and be able to do the proper mapping. But are there tools or are there like advice
There are.
to
Yes,
achieve
there
this?
are. And again, I'm not marketing those tools. I'll give you a couple of them that I've used. As I said, right, these are more personal things. So um, one that I've used is Cloud Pack for Data from IBM, because they have recently introduced, they have uh, basically acquired a firm called Manta that does the data lineage for us. Data lineage from the calling green screens all the way to the vSAM files, what data elements are being done. So we have used Cloud Pack for Data to get that data lineage done. If you do not have vSAM file, you have DB2, you can use likes of Collibra, Atlassian, so Elation. So those are tools that are already available in the market that you can use. I've used Collibra, I've used Elation, I've used Cloud Pack for Data. For COBOL, I've found Cloud Pack for Data, that to Manta, the most useful for us. And let's stop off the perfect. Hope that was helpful, IMB.
Yeah, absolutely. Thank you so much.
Sure.
Okay.
Akhil?
I had one last question. So, what do you think of the role of AI could be in this entire process of migration, be it in data discovery or data transformation or the reconciliation? What do you think AI? Where do you think AI can help us?
Okay. Data discovery, as I said, right? AWS Transform, it's built on AI. It just lacks. It just enables you to form the correlation between programs. Data modeling, data mapping, we have started doing through AI now. Data mapping, we call it data mapper. Uh, Target state is something that you have to do ground up. No AI. AI can assist you, but you have to use real eye for that. Defining the target state. And then transformation, yes, you have business rule. You can use that natural language that COBOL code spits and use that as prompts to build your target state. So AI can be used in every of this 5-step process. And we have started using it. It's a very strong piece. Everyone should be using it. I started counting tokens for how many tokens my teams are consuming. That tells me how many AI users I truly have.
Yeah, that's great to know. Yeah, thank you, Vishal.
Of course.
Okay. So
Over to
there
you,
are
Michael.
there are always two house questions, but I know I had to, kind of cut Fajin short on his questions. So I want to just give him one more opportunity if he has a question that he was going to ask that I said we should let others to come up before I ask the two house questions. Fajin, do you have any outstanding question?
I mean, I know I don't want to. I respect the time. Yeah, I'll pass
Okay.
now. Yeah.
Oh, thank you. You're very
Yeah.
generous. Okay.
Thank you.
So,
Yeah, I'll connect with Vishal. Sorry. Can I connect with you in LinkedIn and ask questions if you can? Yeah.
Of
Thank you.
course.
Thank you.
You guys have been a great audience. Thank you so much for
Okay.
having me over here, Michael.
So Vishal, please, we have just two questions. I'm gonna say them
Sure.
so that you can answer them, together, and you know how many minutes you are okay to spare us. In addition, I know we are now over the time. So it's we always ask our guests two questions, and they are questions that we tend to get inspiration from the answers on. So one is how their journey has been. It's always interesting when we hear how people didn't originally plan to be in the space they are now expert at, and that natural progression. We would like to hear yours. What's your story has been like? Then the second question is, uh, with the entire landscape of things right now, if someone was starting out afresh, if there's a version of you that is now starting out now, what would be your advice to that person? So those are the two questions.
Okay. First and foremost, I'll take the first one first. Um, what do I tell it to my team members? And what I've learned is the skill set that we need, all of us need, is accountability. No AI would give you that, right? Yes, there are hard skills. That's where AI is coming after. Soft skill, people think about it just communication. No, it's about accountability. It's about ownership. It's about common sense. That's something that we all have to develop. We all have to build. And that is something I tell it to everyone in my team and my peers and everyone. And that's how I would definitely tell it to you guys as well. Accountability, don't, there's no shortcut to it. Get things done. That's what goes up at the end, right? That's one. Second is, what if I was freshly starting? What I would have told myself 20 years ago? Probably invest in Nvidia. No, just kidding. It would have been, uh, it would have been basically around never make learning an optional thing or upskilling, right? Lucky for me, I learned it fairly early in my career that upskilling is not optional, but upskilling is something we should continue doing. As I said right earlier, when I started, the technology life cycle was 10 years, 8 to 10 years. So could I have been ahead of the curve? Maybe. On the hindsight, you'll always have that option, right? But I would have definitely would love to invest more time in coding, which I don't get a chance. My role doesn't allow me to do that anymore. But I would spend more time in coding and doing fun things. Like I do it currently, all my cloud agents run on my still do that. 20 years ago, I would have, yeah, done things a little different, spend more time in upskilling myself.
Okay, thanks. You give us a super short version of your journey. Like the one of the first question was a bit also more like, how did you end up here? Did you start originally from a data space and like exactly what you were
Oh,
doing 20 years ago?
yes.
Uh,
So I was in, as I said, right, Michael, in the beginning itself, I'm a visual thinker. So I ended up in the data space uh, from many courses, from many dimensions, right? One was I've always been into architecture and integration. I learned that enterprises will never be a homogeneous system. It will always be heterogeneous. So learn started with integration, then started getting into data because what are we integrating? Data, right? So starting getting into data, and that's where data is like I'm call myself a data junkie now. So started with an engineer. As I said, I was a Java engineer, integration space, security. With security came in with data, and that's how it got deep into data. Always prefer having people T-shaped individuals when you're deep into data, but I know what is going on in distributed systems as well. So I'm not just living with the blinders on with data. So that's how I got into data. Data has gone more complex. That's where it's become more fun. So data has gone from structured to semi-structured, not to unstructured. AI engines are running on all of it. So that's how my journey has been. Started as an engineer, developer, integration, security, architecture, ultimately landed up in data.
Oh, thank you
I've,
very much.
and I've done a lot of courses online to upskill myself on data. Mendelian architecture that Akhil was talking about, I wrote article on this as well of how we can derive and save value, operations FinOps as well. So I've done a lot of academic researches on that.
Where can we follow some of your academic writings so I can
So
share if
I
you
am
want me to
there
share?
on Google Scholar as well.
Google
Let me.
Scholar. Okay.
You will find that on my LinkedIn profile as well.
Oh, okay. All right. I think I tried to share your LinkedIn profile, so maybe.
Yes. So I'll put it in the chat as well.
Okay, thank you very much. I know I have to also let you go. You've got a family, you've got other things, and Monday is a prime day. I'm sorry that we have taken so much of
No, it's
your time
perfectly
on it.
fine. It's always
Uh,
fun to talk about and learn more from the fellow engineers.
Thank you very much. So with that, we'll bring this session to a close. Thank you to everybody who has joined today and stay till this time. The session is recorded. Once I end it, the recording is going to stop, and then in 2-3 days we'll put it up so you can rewatch. I know it's a lot. In fact, for me, I'm going to rewatch because I think there are some strategies there that maybe with my stage where I am, I can't use them, but I'm gonna get into a stage where I can, be able to implement them, and I want to know that I have this handy. So thank you very, very much, and to everybody, thank you. So I'm ending the session now.
Perfect. Thank you.
So